We will now be discussing about wave motion. We are referencing Physics for Scientists and Engineers by Serway and Jewett. Disclaimer: this video is intended as instructional medium for engineering students. This video can be downloaded for free at www.youtube.com. This video was uploaded on YouTube by the creator for audio-visual purpose during class discussion and on online learning. This video is not regulated by the institution. Any use of this video other than its intended purpose is a viewer's responsibility. The creator warrant or allow the free use of this video only for instructional purpose and reference. Learning objective. At the end of this presentation, students will be able to learn on the propagation of a distance, analysis model, transverse wave, the speed of waves on strings, and reflection and transmission. First off, I would like to give credit to the owner of the uploader of this video. I have seen this video and I cannot help but to share this with you because inasmuch as I have read about waves and with the multiple researches that I have done for my classroom lecture, from then since now, I can safely say that this is the best and the simplest presentation of wave that everybody could understand. I have utilized this available educational media resource because this is far greater than I can explain this topic.
We're all familiar with waves, especially water waves. But sound and light are just as wavy, and they're even more common. Luckily, we can learn a lot about sound and light waves by looking at water waves. Here are some continuous circular waves being made by a point source, as shown from above, so that we can see their crests moving outwards. We can also show the waves side on, where it's easier to see what's making them. For example, here a rod is being dipped in and out of the water. How would you describe a wave to a friend? We can describe the waves using their wavelength, which is the distance between their crests. It's also the distance between their troughs, because this is the same distance. We'll call the wavelength lambda, which is a letter that stands for L in the Greek alphabet. Now we'll fade out the overhead view and just look at the side view to make the waves look simpler. And here's a boat to show some of the strange properties of waves. How is the boat moving differently to the wave? Notice how the wave is moving left to right, but the boat only moves up and down. You can check this out next time you're in a boat. The speed of a wave is how fast it's travelling from left to right here, and is usually given the symbol v, which stands for velocity. Velocity is another word for speed. Notice how the speed of the wave is constant, and each crest moves at the same speed as the others. But the boat's up and down speed changes, and you can see that it's moving fastest in the middle of its cycle. This cyclic type of movement is called simple harmonic motion, and we'll cover that later. A pendulum is another example of simple harmonic motion, although it moves horizontally instead of vertically. The amplitude of a wave, with symbol A, is how high it moves up and down compared to a flat, calm surface. Higher amplitudes are caused by the source having more energy and dipping further into and out of the water. The guy on the boat would notice that he would rise and fall more, so he'd get a more energetic ride. The wave's frequency, given the symbol F, is the number of waves being made each second. The frequency is also the number of waves passing by the guy in the boat each second. Here, only one wave is passing per second, so scientists say that its frequency is 1 Hertz. Hertz is the unit of frequency, and it just means waves per second. It's usually shortened to Hz. This unit was named after the famous German scientist Heinrich Hertz, who proved the existence of electromagnetic waves, which we'll explain in another video. Interestingly, Hertz was not only a clever scientist, he could also speak Arabic and Sanskrit. Both of these languages are steeped in scientific and mathematical history. Does anything happen if we increase the frequency by dipping the source in and out more often? Let's double it, from 1 to 2 Hertz. Looking at the wavelength, we can see that it gets shorter. We doubled the frequency, and the wavelength looks about half what it was before. This means that when frequency increases, wavelength decreases, and vice versa. So we can say that frequency and wavelength are inversely related. That makes sense. When we increase the frequency, more waves are squeezed in, reducing the distance between them. We've looked at wavelength, frequency, amplitude, and speed. In the next video, we'll show how these can be mathematically connected to each other with the wave equation.
The world is full of waves. The two main types being mechanical waves and electromagnetic waves. In the case of mechanical waves, some physical medium will be disturbed. In our feeble example, elements of water are disturbed. Electromagnetic waves do not require a medium to propagate. Some examples of electromagnetic waves are visible light, radio waves, television signals, and X-rays. Here, in this part of the book, we study only mechanical waves. Okay, for example, we have here a rope. Let us illustrate this as a rope. We have here a rope, okay? Mahabang rope. Kapag tayo mga taong bukid dyan na kagaya ko, no? Kapag tayo ay mag-uulan ng kalabaw, yung tinatawag dito, yung susuga ng kalabaw, di ba, mahaba yung ating panuga. Ay minsan pinaglalaroan natin yun at hinahawakan natin sa dulo, bigla nating iwinawag-iwas, makikita natin na nagpo-form ng parang ganito, ano? Alright. Yung ating nagkakaroon ng parang waves. Pero ang pagtaas at pagbaba mo ng kamay, up and down. Pero yung waves, pagpunta niya, papunta doon, ano? Sa diretso, papuntang. So, ang tawag daw po doon ay transverse wave. Kasi ang propagation mo, up and down, pero yung takbo ng wave ay padiretso, no? naka-perpendicular doon sa line of action ng propagation. So we call that as transverse wave. At ang isang ano raw, ang isang pitik pataas o pitik pababa, ang tawag daw natin doon ay pulse. Pulse is formed and travels along the string with a definite speed. Okay. A single bump called a pulse is formed. Kapag nagkaroon tayo ng single bump, magkakaroon daw ng travel ng wave along the string. Okay, yan yung key takeaway natin. Ano? Transverse wave, a traveling wave or pulse that causes the element of the disturbed medium to move perpendicular to the direction of propagation. Okay. Yun yung example na pinakita natin kanina. If the propagation is up and down and the direction of wave is perpendicular to the line of action of the propagation, then it is called transverse wave. On the other hand, for example, if you can see, this is spring here. At itong spring na to, itinulak ko, no? Hinila ko at patulak, hinila ko patulak. Magkakaroon ng parang wave yan. At yung wave na yon, parehas doon sa direction ng paghila at pagtulak. Ang tawag daw po doon ay longitudinal wave. Because the line of action is parallel to the direction of propagation. Okay. So sana maliwanag tayo, no? Transverse wave, pagka yung line of action of the wave will be perpendicular to the propagation. Kapag along the propagation, that will be longitudinal waves. Wave is a continual disturbance, oscillation, or vibration that transfers energy from one location to another. Oscillation, regular variation in magnitude and position. This is something that is moving up and down, left or right, over and over again. A wave transfers energy without transferring mass. If we have a single oscillation, we call it a pulse. Characteristics of waves. Wavelength, lambda. Amplitude, alpha. Frequency, f. Period, t. And speed, v. Wavelength, lambda. Wavelength is the distance between consecutive corresponding points. For example, this part is called the crest, and the lower part, the valley, is called the trough. So, correspondingly, this crest and the consecutive one will be called the corresponding points. Therefore, from here to here is what we call wavelength. Correspondingly, for example, in the middle, we have here in the middle between the crest and the trough, from here to here is one wavelength. Another example is halfway from the midpoint to the trough. So from here to here is also called one wavelength. Notice that they are all equal. The unit of wavelength is meter. Amplitude A. Amplitude, the distance from the middle of the wave to the top of a crest or to the bottom of the throat. For example, this is the middle of the wave. The distance between the middle to the top of the crest is said to be amplitude. Also, the distance from the middle of the wave to the bottom of the throw is also called amplitude. The energy of a mechanical wave is directly proportional to its amplitude. Frequency F. Frequency is the number of occurrences of a repeating event per unit time. The number of complete wavelengths produced per second. In equation, F is equal to the number of wavelengths divided by time. The unit of frequency is hertz and is equal to cycles per second. Sample problems for frequency. Frank is making waves on a rope by moving his arm up and down, which he does 20 times in 10 seconds. What is the frequency of the waves that Frank is creating? From the equation of frequency, frequency is equal to the number of wavelengths divided by the time. Frequency is equal to 20 divided by 10 seconds. The frequency is 2 oscillations per second, or 2 hertz. Period T, the interval of time between successive occurrences of a cyclic phenomenon. Period T of a wave is the time interval required for the element to complete one cycle of its oscillation and for the wave to travel one wavelength. So one wavelength, the distance between one wavelength or the time it will take to travel the distance of one wavelength is equal to the period T. T is equal to time over the number of wavelengths. The unit of period is equal to second. Period example. Kelly is floating on an inner tube in the ocean and notices that she bobs up and down 6 times every minute. What is the period of the ocean waves on which Kelly is floating? Period is equal to time over the number of wavelengths. Therefore, the period is equal to 60 seconds because that is 1 minute divided by 6 times because the problem states that 6 times per minute. Therefore, the period will be 60 over 6. The relationship between frequency and period. Frequency and period are reciprocals of each other. F is equal to 1 over T, or T is equal to 1 over F. Speed of waves. We already know from the preliminaries that velocity is equal to the distance over time. Now, the characteristic of a wave that is measured in meters is wavelength, and that will correspond to the distance. And the characteristic of a wave that is measured in second is period. Therefore, following these two notions, we can say that the velocity is equal to the wavelength over period, or lambda over t. Note, since period and frequency are reciprocals, velocity or speed is equal to the frequency multiplied by lambda. Wave speed example. What is the speed of a water wave that has a wavelength of 8 meters and a period of 4 seconds? So we're given wavelength, lambda. We can directly substitute it to the equation v is equal to lambda over t. Therefore, v is equal to 8 meters divided by 4 seconds. Therefore, the velocity is 2 meters per second. Number 2, what is the wavelength of a sound wave with a speed of 331 meters per second and a frequency of 500 hertz? We are given the frequency, so we can use the equation v is equal to the frequency multiplied by lambda. We are asked to find for the wavelength, which is lambda. Therefore, lambda is equal to 331 meter per second divided by 500 hertz, and it will give us lambda equal to 0.662 meters. In this chapter, we will be focusing on mechanical waves. Here are some characteristics of mechanical waves. All mechanical waves require some source of disturbance. Number 2, a medium containing elements that can be disturbed. And number 3, some physical mechanism through which elements of the medium can influence each other. For ease of uploading, we shall temporarily terminate our discussion and be back for video number 2. Muli po, ito ang inyong Sir R Squared na nagsasabing, ingat lagi, kain dami, at tulog aga. Ibinabalik ko ang lahat ng parangal at papuri sa Diyos Amang makapangyarihan sa lahat. Mula ngayon at magpakailanman. Amen. May God bless us all. To God be the glory.